right, we are starting a new unit here on simplifying rational expressions. Rational expressions. I think you'll kind of enjoy this unit, just factoring and crossing stuff off a whole lot, which I find, fun. But what you need to know is what rational means. So what is the root of the word rational? Ratio. Ratio is the root of the word ratio. And what is a ratio? Sorry, say it again. You don't know? You've heard that. How would you use ratio in a sentence? The ratio of favorite one is like boys to girls. Favorite one. All right. So we can write like the ratio of boys to girls is 3 to 5 in this class. So you can write 3 to 5 this way, but we can also write it as a fraction. So ratio is really just fancy for fraction. And so what I like to say is rational fractional. And so everything that we're doing in this unit for like the next almost 2 weeks has to do with fractions, essentially, and simplifying fractions. So today we're starting just learning some, hopefully you know these, but exponent properties. So this goes back. We've done this before. 3x squared times 4x to the 5th is what? What number do you get? 12. Very good, because 3 times 4 is 12. All right. What about the x's? We want to multiply x squared times x to the 5th. What does that give you? What's x squared times x to the 5th?
7.
X to the 7th. Very good. X squared times x to the 5th is x to the 7th. Why is it x to the 7th? You add the exponents. Yeah, when they have the same base, we add the exponents to get x to the 7th. The base stays the same. We add the exponents. Okay. Same rule applies on number 2. So we're going to multiply 6x to the negative 3 power times 2 times x to the 8th power. What number do you get? 12. Again, 6 times 2 is 12. Numbers are normal. We know what to do to multiply numbers. Okay, and then what do you do with x to the negative 3 times x to the 8th? What do you think you get? X to the 5th. It is x to the 5th. Why? Same base. We add the exponents in a product. All right? When you have the product with the same base, you add the exponents. Same rule applies. Okay. So then my question is, what if you have a division problem? X to the 8th divided by x to the 5th. If they have the same base, what do you think you do? You subtract the exponents. Top minus the bottom. So 8 minus 5 gives you x to the 3rd. Okay? So this is what we're doing today. We are subtracting the exponents. Top minus bottom. All right? That's what we're doing. That's the rule. If they have the same base, you can subtract the exponents. So here we go. Example 1. Simplify the expression. Example 1. Simplify the expression. We have 4x to the 5th over 12x cubed. These are rational expressions, rational fractional. You can see we've got a big old fraction there. So we call these rational expressions. And we're going to take this in parts. I'm going to look at similar things here. I have a fraction, 4 over 12. What can I do with 4 over 12? I can divide. What can I divide by? 4. Yeah, I can divide top and bottom by 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. So you can reduce your fraction. Very good. All right. Now I've got some things with the same base. We have x to the 5th divided by x cubed. What can we do when they have the same base? Subtract the exponents. The rule is your base goes in a numerator. If you're going to use the subtraction rule, the base stays the same. It stays in a numerator, and you do top minus bottom, 5 minus 3. That gives me a 1 over 3, and then we get x to what power? X to the 2nd. This is a wonderful answer. Do you need the 1? Is the 1 doing anything for us? No. So it would be okay to have x squared over 3 as an answer as well. Okay. Either one of these are the same thing. Super. Letter B. 14x to the 4th over 7x to the negative 5. So I'm going to keep a fraction, and I have numbers here. I have 14 over 7. What can I do with 14 over 7? What can I divide by? 7. Sure, divide by 7. So 14 divided by 7? 2. 7 divided by 7? 1. Then I have x to the 4th divided by x to the 5th. X to the 4th divided by x to the 5th. They have the same base. We put the base in the numerator. What do we do to the exponents? Subtract them. 4 minus a negative 5. Be very, very careful. 4 minus a negative 5 is really what? Adding. Minus a negative. Negative times negative really turns to positive, and so we get 2 over 1. X to the 9. Do you need the 1? No, you don't need the 1. 2x to the 9th is the same thing. All right. You okay with this so far? Watch your negatives. All right, letter C. We have negative 21, x to the negative 4th times y to the 7th. All divided by 15x squared, y to the negative 5th. So, I'm going to start with my numbers. Negative 21 over 15. What can we do with those numbers? What can I divide by? 3? Divide by 3. All right. Negative 21 divided by 3 is? Negative 7. And 15 divided by 3 is 5. Good. All right, now we look for things with the same bases. Same base here. We've got x to the negative 4 over x squared. They have the same base that we're going to keep in the numerator. What do we do to the exponents? Subtract. Negative 4 minus 2. Negative 4 minus 2. It's like the division sign. It's like a big giant subtraction. All right. We also have the same base of y. Same base of y here. So I'm going to put a y in my numerator and subtract my exponents. 7 minus a negative 5. 7 minus the negative 5. Be careful. All right. What do we get with this x here? X to what power? Negative 6. And what do we get with the y? Y to what power? 12. Very good. Again, negative times negative is a giant positive sign. So 7 plus 5 is 12. Now, negative exponents. None of the answers on the worksheet are going to have negative exponents. Do you know what a negative exponent does? Negative exponents, I like to think of them as unhappy. So x to the negative 6 is unhappy up here in the second story. And he wants to move downstairs to the first floor. He's got bad knees. All right? So he wants to change places. And when he changes places, he is no longer negative. He changes sign. Okay? That's just what happens. It was like me moving from the first story to the third story. So much better. Much happier. Okay. That was a long time ago. What about the y to the 12th? Does y to the 12th need to move? No, he's perfectly happy upstairs. His knees are fine. All right. So make sure none of your answers have negative exponents. Negative exponents mean move it. It's really mathematical. It's a highly mathematical definition. Move it. That's it. Okay. What do you notice is different about letter D? It's got parentheses with the exponent on the outside. Sure. Parentheses mean we need to simplify inside the parentheses if we can. So what we're going to do is we're going to leave that power of 2 for a little while, and we're going to try and clean up on the inside. So we can do a little cleanup. I have 2 over 6. What can those divide by? Divide by 2, divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. I can also clean up my x's here. I have x to the 4th divided by x to the negative 3. The x goes in the numerator, and I'm going to subtract my exponents for minus the negative 3, which is really what? 7, yes. So you're thinking, can I do that in my head? Absolutely. You would get x to the 7th. Okay. Do I need the 1? No. All right, so we have x to the 7th over 3, quantity squared. Now that we've cleaned up everything we can inside the parentheses, now I'm going to deal with this power. What does quantity squared really mean? Right now, 2 times. So we would have x to the 7th over 3 times x to the 7th over 3. So if you want to, you can always go back to the meaning of powers. It says repeat 2 times. So we're going to repeat it and multiply. And I can do that. What is x to the 7th times x to the 7th? If they have the same base, what do you do to the exponents? Add them. So we get x to the 14th. And what's 3 times 3? 9. Okay. So that's a great answer. But the other thing that you could do, if you can always go to the meaning of exponents, that always works. The shortcut is everything has its own little exponent. This is a 3 to the 1st power. And this is x to the 7th power. When you have a power raised to a power, you multiply those powers. It's kind of like distributing. Everything gets multiplied by 2. So we would have x, 7 times 2 gives you the 14. And here, 1 times 2 gives you 3 squared, which is 9. So you can multiply the powers as well. Okay. Any questions on these 4? All right. Seems like a lot, but they're all different, so it's really important that we do them all. Letter E, 2x cubed over 3y to the negative 2. quantity to the negative 2 power. What do parentheses tell you to do? We can work inside the parentheses first, okay? So can I do any cleanup on the inside? There's no cleanup that we can do. I can't reduce the fraction. I don't have same bases. So I actually can't do anything inside. So instead, what I'm going to do is worry about my power raised to a power. Everything has an exponent. This is 2 to the first times x cubed. This is 3 to the first times y to the negative 2. We are going to distribute our power, multiply all those powers together, which is going to give me 2 to what power? 1 times negative 2 is negative 2. We're going to get x to what power? Three times negative 2 is negative 6. In the denominator, we have a 3. What power does he get? 1 times negative 2 is negative 2. And last, what color have I used? Pink, I guess. Y to what power? 4, yeah. Negative 2 times negative 2 gives me positive 4. Okay. Now, what do I do with all those negative exponents? What does 2 to the negative 2 want to do? Move. Where does he want to move? X to the negative 6 also wants to move. 3 to the negative 2 also wants to move. He's downstairs. Where does he want to move to? Upstairs. Yes. All right. So 2 to the negative 2 was unhappy upstairs. He wants to move downstairs where he is no longer negative. X to the negative 6 is unhappy upstairs. He wants to move downstairs where he's no longer negative. 3 to the negative 2 wants to move upstairs where he is no longer negative. What does y to the 4th want to do? Stay in the denominator, y to the 4th. The last thing we can do is just, what is 3 squared? 9. 2 squared is 4. X to the 6th, y to the 4th. And that's our final answer. Okay? All right, letter F. We have quantity, 2x squared, y to the negative 4th, quantity cubed, all divided by 12, x to the negative 2, y to the 5th. Again, parentheses tell me I need to try and do stuff inside of there, but I don't have any cleanup I can do. So my next thing I can do is worry about this power of. So I have 2 to the 1st. All of this is being cubed. What am I going to do with my powers raised to a power? Multiply those powers. That's going to give me 2 to what power? So to the 3rd, yes. 1 times 3 is 3. That's going to give me x to what power? 6. Yeah, 2 times 3 is 6. Y to what power? That's right, negative 12. Negative 4 times 3 is negative 12. I didn't touch anything in the denominator yet. So I can do a little bit of cleanup here. 2 cubed is 8. X to the 6th, y to the negative 12 over 12, x to the negative 2, y to the 5th. All right, now we can do some real cleanup here. I got numbers, I got a fraction. What can I do with 8 over 12? What can I divide by? 4. That's right. So smart. 8 divided by 4 is 2, and 12 divided by 4 is 3. X to the 6th divided by x to the negative 2. What are we going to do with our exponents? Subtract. Oh, that's right. 6 minus the negative 2. Minus the negative 2. Be careful. And last, we got a couple of y's. Y's have the same base. So the base stays in the numerator. And we're going to do negative 12 minus 5. Negative 12 minus the 5. So we get 2 over 3. We have x to what power? 8. And then we have y to what power? Negative 17. And what does y to the negative 17 want to do? Move, go downstairs. Yep. So we get 2 over 3. We have x to the 8th, which is perfectly happy upstairs. Y to the 17th is happy downstairs. Again, a lot of this you can probably do in your head a lot more easily. But that's not the purpose of notes. All right, letter G. What is this called? 3.2 times 10 to the 6th. Scientific notation. Scientific notation is actually just properties of exponents. This is the same exact idea. We have a number here. 3.2 divided by 1.6. What is 3.2 divided by 1.6? Also known as 32 divided by 16. 2 over 1, just 2. And then we have times. That's great. And here we have things with the same base. They both have a base of 10. So you're going to keep the base the same and do what to the exponents? Subtract. 6 minus 4. Same exact thing. So we get 2 times 10 to the 2nd. Same exact rules. Same base. Subtract the exponents. Letter H, we have 72,000 over 0.0036. What do we want to do with those crazy numbers? Write them in scientific notation. So we're going to move the decimal a few places here so that we get a number less than 10. So we have 7.2 times 10 to what power? 10 to the 4th. We move the decimal 4 places. 72,000 is a large number, therefore your exponent is a positive value. Here, I need to move the decimal place. 3.6 times 10 to what power? Negative 3. This is a decimal. This is a number less than 1. If it's a number less than 1, the exponent is a negative number. And the same thing applies. What is 72 divided by 36? 2. And then 10 to the 4th over 10 to the negative 3. They have the same base. And we get to subtract. 4 minus the negative 3 becomes what? 7. minus a negative is really plus. So we get 2 times 10 to the 7th. Okay? Any questions for me?